Hey guys, today we're working with algebraic expressions that involve indices. And in particular, we're going to learn about how to multiply algebraic expressions that involve indices, that involve powers. The rule is simple. The rule is, when we are multiplying and we have indices involved, we add the indices. It's that simple. When we multiply, we have the indices, we actually add the indices up. Now, let's do a couple of examples. You'll notice how simple and easy and straightforward it is. Okay, let's look at these examples to understand this much better. We said when we have algebraic expressions and we are multiplying them, we add the indices. Basically, adding the indices. That's all we do. So we have y to the power of 3 times y to the power of 5. Multiplication means we add the indices. So simply y to the power of 8. 3 plus 5. 3 plus 5 is 8. Y to the power of 8. It's that simple. Another one. X to the power of 3 times x to the power of 4. We know we're multiplying with indices. We simply add. Equals x. The base stays the same. We have the same base. We can actually do it. So y to the power of 8 is there because the y's are the same base. Here, x times x, x to the power of 3 times x to the power of 4, the same base stays. 3 plus 4, 7, x to the power of 7. Again, m to the power of 5 times m to the power of 6, the same base. M, and we are multiplying, so we add the indices. 5 plus 6, m to the power of 11. Let's do some more. 3x squared times 2x to the power of 4. We have pronumerals and we have numerals. So the numerals, simple. 3 times 2. 3 times 2, 6. Then, do we have the same base? Yes, we do. X squared, x to the power of 4. We are multiplying, so we add and we write x power of 6. X to the power of 6. So our answer is 6x to the power of 6. 3 times 2 is 6. Same base, x and x. So write our x, we add the indices. 2 plus 4 is 6. Then we have another one. 12 y to the power of 3 times 4 y to the power of 7. Try doing this one yourself. What are we going to do? We have our numerals first. Always numerals are written first. 12 times 4, 48. Now what? We have the same base, y to the power of 3 times y to the power of 7. So our base is y, and we simply add the indices. 3 plus 7, so 48, y to the power of 10. Another one, 6t to the power of 3 times 3t. We have numerals. 6 times 3, 18. Remember to do these with me. And we have a multiplication. We have the same base, t and t, so the base is going to be t. And make sure when you're writing your t's in algebra, you make them look like a t, okay? I've seen students just quickly, they write their t's like that, it looks like a plus. No, make sure you make it look like a t. Just a tip there for you. 6t to the power of 3 times 3t. Now, we notice there is actually nothing there. So what are we adding? In fact, there is. It's actually a 1. There is a 1. It's an invisible 1. Always remember that. Times is plus. So t to the power of 3 times t to the power of 1. 3 plus 1 is 4. 18t to the power of 4. It's that simple, guys. Very easy. Now we're going to do some more complex ones. Alright, let's do some more fun. Okay, here we have 5x squared times 3y times 2x. Again, we are multiplying algebraic expressions. We are multiplying the terms, but we have indices. So what do? Let's do the same thing and we follow the same rules. 5x squared times 3y times 2x. We know we have numerals. We multiply the numerals first. 5 times 3 times 2. 5 times 3, 15 times 2, 30. We have our x squared times y times x. We look for the same base that are the same. Here we have x and x. So we write our x. We have 2 here. And we know there is an invisible 1 there. So we know we add the indices. When we multiply, we add the indices. 2 plus 1, x to the power of 3. Then we write down the y as it is. It has nothing to multiply with. So our answer, 13x cubed y. Next, 4x squared y to the power of 3 times 5x y to the power of 2 times 2z to the power of 2. Again, we do the numerals first. 4 times 5 times 2. 4 times 5 is 20 times 2, 40. They're done. Now we look for our indices. We look for our same bases. X and x here. Do we have another x? No, we don't. X squared times, there's another one there. So we add the ones with the same base. X, 2 and 1 make 3. Now we look for the y's. We have y to the power of 3 and y to the power of 2. Same base, which is y. 3 and 2. 3 plus 2 is 5. And lastly, we know there's a z here. It doesn't have another base it multiplies with. So z power of 2. There's our answer. 40x to the power of 3, y to the power of 5, and z to the power of 2. Simple answer. We have to follow certain rules. We add the indices when we are multiplying in algebraic expressions. 6b squared times 3a squared b times 3c. We work them out. We write down our numerals first. 6 times 3 times 3, 54. And then we work with our pronumerals. B squared times, there's another b here. We know there's an invisible 1. So b squared and b, we know we add them up. We have b to the power of 3. And we have a squared. Does it have anyone else to multiply with? No. A squared and the c at the end. 54, b to the power of 3, a to the power of 2, and c at the end. Last one. We do the numerals first. 16 times 2, 32. A squared, does it have another base that is an a? No. A squared. M, it has to the power of 1. It's an invisible 1. M times m to the power of 2. We add the indices. 1 plus 2, 3. 32 a squared, m to the power of 3 is our answer. So we know the rules. No matter how large or how small the algebraic expression, when we're multiplying and we have the same base, we add the indices.